Alright, Assalamualaikum and very good evening to all.
Waalaikumsalam, sir.
Ni saya punya ni tak keluar. Sekejap Okay, kita sambung dengan contoh-contoh masalah. Right. So let's go to the first problem, introductory problem, simple problem. Okay, let's say we have a case of a ball being kicked by a player. Okay, and this ball, the mass of this ball is 2.5 kg. So after being kicked by the player, this ball accelerates at an acceleration value of 40 meter per second square. The question is how much force being given to the system. Silakan. Soalan mudah Okay, I wrote down the information. We have mass. We have acceleration value. So how much force?
Hundred Newton.
100 Newton. Good work. Alright. Semua dapat? Senang kan? Let's go to the second one. Okay. Case of friction. Okay, this is a case of friction. Let's say we have a shoe and a surface of cord. Okay. So let's say the coefficient of friction between these two surfaces, the shoe sole and the cord surface, is 0.56, and the normal reaction force for this system is 350 Newton. Okay, the question is how much horizontal force, how much force we needed in order to make this shoe slide. Jadi untuk case macam ni, first you need to find out how much net force you have in the system. Okay, dalam case friction, find force net dulu. So force net equals to force, normal reaction force, time with the coefficient of friction. Baru kita tahu berapa force ada dekat dalam sistem ni dulu. Kita dapat?
$196.
Okay. If you have this one, this means that the normal reaction force is 196. So how much force needed horizontally to make this shoe moving? Berapa banyak force kita perlu bagi untuk gerakkan kasut ni? Untuk gerakkan sistem ni? It will be, horizontal force needed will be more than 196. Bergeraklah kasut tu because 196 adalah berat kasut tu sekarang. Okay, inclusive of friction and also force by the wearer. So kalau kita include the force and the friction, the total force ataupun net force of this system is 196 Newton. So to make it move, we need force more than 196 Newton. Ni case apa ni? Coefficient of friction. Okay, let's go to the next one. Still friction. Okay, we have football player training tackling. Okay, so this football player tackle a tackling sled, and this tackling sled, the mass of it is 670 kg. Ini mass. Okay, remember this. When you see kg, it is mass. When you see Newton, it is weight. Okay, to change weight to mass, we need to divide with 9.81. To change mass to weight, we need to multiply with 9.81, which is gravitational. Okay, so here dia bagi tahu sled ni mass dia 670, sorry, okay, the information said the sled, okay, the weight of the sled is 670 Newton. Okay, ini dia punya weight. Okay, and the coefficient of static friction, so now we have two coefficient. One, coefficient of static friction equals to 0.73, and number two, coefficient of dynamic friction equals to 0.68. So the first question, how much force, okay, how much force needed horizontally to make the sled start moving? Sama macam case kasut tadi. So first thing we need to find out what is the sled net force. Equals to force normal reaction time with coefficient. So to start moving meaning from stop. So we need to use static friction. Berapa dia punya normal reaction? Adalah berat dia adalah normal reaction dia. So you have 670 times with 0.73. Berapa kita dapat?
489.1.
489.1
89.1
apa?
Newton.
Newton. Okay, ini adalah net force dalam sistem. So how much force needed in order to make it move?
More than 489.
Yes, betul. More than 489.1 Newton. Okay. Second question. How much force needed in order to keep it moving? Kita akan pakai coefficient. Kita akan pakai coefficient dynamic. So we need to know net force dalam sistem dulu equals to 670. Now the coefficient being used is coefficient of dynamic friction. Apakah?
455.6 Newton.
So the answer for the question, how much force needed?
More than 400.
Yes, betul. More than 455.6 Newton. Okay. Now let's see. There are a person. Okay, a person sitting on the sled, and this person, the weight, the mass of this person is 100 kg. Okay, so please find out how much force needed to make the sled moving, and please find out how much force needed to keep the sled moving with the new additional mass. Kita kena cari dulu new normal reaction force of the system dulu. Okay, so the first task is find out what is the new normal reaction force dia. So normal new dia ialah sled plus person. Sled we have 760 person we have 100 kg. That is mass. Nak jadi week, we need to time with 9.81. Okay, yang ni dulu. Berapa dapat? What is the weight for the new complex? What is the force, normal reaction force for the new complex?
768.1 Newton.
Kamu biar betul 700. Biar benar kamu ni.
Bukan lah.
Bukanlah 100 kali dengan 9.81. Dah banyak dah boh.
Total semua.
Dapat berapa? 981 campur dengan 670. Tu dia. 1651 Newton. This one is 670. This one is 981. Kali 100 kan? Point tu. So, orang tu saja weight dia dah 981 Newton. Campur dengan slab 670 Newton, you end up dengan 1651. This is the new normal reaction force dia. Lepas tu guna yang sama lah. So, number 3, how much force needed to make it move? It will be 1651 times with 0.73 coefficient of static. And then number 4, it will be 1651 times with 0.68 coefficient of dynamic. Dapatlah jawapan baru dia berapa? Berapakah?
Untuk yang statik 1205.23 Newton.
1205.3 Newton. So answer dia need to be more than, ini the change of. So the final answer is the force needed need to be more than 1205.3 Newton. Okay, dynamic
1122.68.
68 Newton. So the answer will be more than 1122.68 Newton. Ni untuk kita guna pakai coefficient of friction, both static and dynamic. So first you need to find out the net force you have within the system, and then baru kita boleh selesaikan isu-isu yang berbangkit. Okay, next one. This one is about the concept of conservation of momentum pun dalam isu kinetics. Okay, where we have momentum 1, velocity 1, this is the first momentum, will always equals to momentum 2, momentum 2. Jadi kalau kita ada case collision, you are going to have momentum 1 plus momentum 2 equals to the new complex, M1 plus M2V. Okay, so the first problem is about this one. Let's say we have two people. Okay, people number 1, people number 2. So the first person is 100 kg in mass. Second person is 90 kg in mass. The first person moved at a speed of 4 meter per second, while the second one moved at a speed of 4.5 meter per second. The question is, what happened to the system after collision? Apa yang jadi pada sistem ini? So we need to find out the new system. This is the old one, M1, M2. The new one is a combination of those two. So please find out the information. Please find out the new system. Okay, so I'm going to list down the information we have. M1 equals to 100. V1 equals to 4. M2 equals to 90. V2 equals to 4.5 meter per second. So please find out the new V. Ada yang salah tak dekat equation tu? Is there anything that need to be corrected on that equation? Ada yang salah tak? Cuba tengok betul-betul. There's something wrong there. Hello, hello. Ada orang tak ada orang ni? Senyap je. Are you in there?
Ada saya.
Okay, ada salah tak kat situ? Sepi je lain ni. That's
Punya
wrong.
V2 dia negatif sir.
Ya, betul. V2 dia kena negatif. Okay. So if you can imagine this one, then it's okay. Kalau tak boleh, please draw the diagram. And then you are going to see the direction of movement. Baru kita boleh masukkan benda ni. Ada orang dia tak dapat bayang. Okay, ada orang dia tak dapat bayang. Because when we talk about collision, it means that two parties move in different direction. So one need to be negative. Barulah kamu boleh selesaikan masalah ni. Kalau selagi kamu tak letak negatif tu, you are not going to go to the right direction. 0.03 meter per second. Negative. Okay. So based on this answer, the question asks you what happened after the collision. What happened to the system? Don't stop here. You know that the answer is negative 0.03. So what happened is both players move in the direction of player 2 after colliding. Barulah habis and you are going to get the full marks. Okay. Alright. Ada siapa-siapa ada masalah dengan isu momentum? If not, we are going to continue with another set of question. Ada siapa-siapa ada masalah? Or can we continue?
Tak ada sir.
Enggak ada.
Boleh sir, boleh.
Okay, sekejap, Okay, we go to the next question, which is regarding what we have learned last week, this week, not last week, this week. Power, work, energy. Okay, kita recall sikit. So, power is work over time. Work is force time with distance. While energy is a combination of kinetic energy, potential energy plus thermal energy. Where, banyak ni E saya. Where in the principle of conservation of mechanical energy, we have KE plus PE equals to constant. Per formula KE equals to half mv square, while PE equals to height kali dengan width. Ni recap. Okay, now the question. Okay, we have a set of stair, tangga. Okay, and each flight, the height of each flight is 20 centimeter, and we have a total of 20 stair. Okay, if we have a person climbing up the stairs, and this person, okay, the weight of this person is 700 Newton, and he done this work in 1.25 second. Okay, so please find out how much work being done, how much power being generated, and finally the change in terms of this human potential energy. Okay, sila selesaikan. Saya bagi satu je tips kat sini. You need to find out the height dulu. Berapa dia punya height? Equals to 20 cm times with 20 steps, resulting 400 cm or 4 meter. Sekarang kamu dah ada weight, kamu dah ada time, kamu dah ada height. So you can calculate all of this. Silakan. Okay, berapa work dia? Berapa force dia first? What is the amount of force we have here? Berapakah force? Remember this. Weight is a force. Okay, berat ialah force. So force here is 700. So the work done is 2800 joules ataupun 2800 Newton meter. Either one is correct. Okay, how about the power? Okay, power is weight, is work over time. So we have the work here. Berapa kita dapat tu? For power?
2,240 watts.
2,240 watts. Okay. And how about the change in term of potential energy? Okay. Bila kita nak cerita potential energy ni, tolong ingat balik what we have learned earlier. Okay. We know that based on the concept of mechanical energy conservation, potential energy is maximum at the apex, and potential energy is zero at the starting and also at the end. Okay, lawan dia kinetic energy is at maximum during the starting of the movement, and at the apex, kinetic energy equals to 0. And when it goes down to the base again, kinetic energy is at the maximum at instant of contact. Ini adalah principle of mechanical energy conservation, where you're going to end up dengan PE plus KE, PE plus EE dah. PE plus KE equals to C. Ini benda ni kamu kena ingat. Okay, so when we go back here, the question asks you about what is the change in potential energy. So we know that potential energy is height times dengan weight. Number 2 minus dengan height times dengan weight 1. And we know that at the base of the movement, potential energy is 0. So tinggal cek satu ni je. Berapa potential energy dia ada? It will be berapa height dia? A total height 4 and weight dia 700 Newton. So as similar as this one. 2800 joules or Newton meter. Either one is correct. Itu cara untuk kita selesaikan isu potential height based on the information that we have. Okay. Can we continue? Change. Okay kah?
Boleh, saya boleh.
Boleh Okay. Okay, next question. Yang ni apa dia buat ni? Vertical jump. Okay. We have a person conducting or performing vertical jumping. Okay, and this person, the mass of this person is 50 kg. Okay, and at instant of jumping, the velocity is 2 meter per second. Okay, so the next question is the first one. A, what is the performer maximum kinetic energy? B, what is the performer maximum potential energy? C, what is the performer minimum kinetic energy? And finally, what is the performer changes of COG? Okay. Itu gambar KE, VE, KE, change of height. Basically, this is change of height. How high it jump. Okay. To solve this one, I give you one clue. Before that, I'm going to write down the information that you have. 50 kg velocity, 2 meter per second. This type of problem where you need to find out KE, PE or whatsoever, please consult this thing back. This is your clue. Okay, principle of mechanical energy conservation, where we have PE plus KE equals to C. You find out C, you can solve all problem. So how to find out C? There are two conditions. One condition, you find out PE. Dekat mana? At the apex. Because at the apex, KE is 0. Or number 2, you find out KE at the bottom. Because at the bottom, PE is 0. Means that at any given point of time, you just need to find out only one in order to find C dia. Jadi daripada maklumat yang kita ada ni, kita lagi sesuai untuk cari PE ke KE first. Which one is much better?
KE.
KE. Okay. So kat mana kita nak cari KE? Kat bottom ke dekat top?
Bottom.
Bottom. Automatically PE kosong. Plus half M we have there 50 and V we have there 2 equals to C. Jadi C sama dengan berapa? 2, 4. 4 kali 50, 200. Setengah daripada 500, it will be 100 joules. Okay, kita dah tahu dah. This system had only 100 joules. So can we answer the first one? What is the maximum KE?
100 joules.
100 joules lah. Dekat mana? Dekat bottom. What is the maximum PE?
100 joules.
100 joules. Dekat mana?
Up.
Top.
Top.
What is the minimum KE? Mudah. Kamu boleh jawab ni. What is the minimum KE? Ingat yang ni? Berapa figure KE paling sikit ada kat sini?
0.
Yes. Dekat mana?
Top.
Top. Okay. COG changes. Nama dia susah tau. Soalan dia, how much is the performer center of mass elevated? Okay. Jangan sakit kepala. Center of mass. Katalah kita ambil center of mass. Dia start kat sini. Pusat dia kan. Lepas tu dia lompat. Sampai sini. Sampai sini dia akan turun. So pusat dia dekat sini. This is actually, the question asked is, how high he jump to je. Means, when we talk about how high, that is PE. KE tak ada lah. Jadi nak cari kat mana PE ni? Dekat bawah ke kat atas? How high? It will be at the top. Saya saja je lukis anak panah ni tinggi. Sebenarnya dia tak lompat tinggi mana pun. Dia lompat sikit je perubahan COG dia. That is the highest point before it goes down, before it goes to apex. So, we are going to consult PE plus KE equals to C, where here we are trying to find the most highest point, which is the apex. Automatically at the apex, KE kosong. So PE equals to C. Can we solve that? PE boleh lah. Weight dia berapa? Okay, weight dia. Kita ada mass dia. Weight dia ialah 50 kali 9.81. Change that first. Time dengan height dia sama dengan 100 joules. So, height dia sahaja ialah 100 joules bahagi dengan 50 kali 9.81. How much you get it? Dapatlah height dia. Empat 490.5. That is the maximum height ataupun maximum change of the COD. 0.2 meter saja. Ni untuk mengaburi mata pihak lawan tu dia nak pandang panjang-panjang. Okay, that is the change of COG. Means that the highest point before they start to fall down. Itulah COG dia. This is how you solve this kind of problemos. Okay. Okay kah?
Okay, sir.
Okay, let's go to the last one before we end the class. Alright, the same one, the same cases. We have a ball. Okay, a ball being tossed upwards. And this ball, the weight of the ball, okay, weight dia is 7 Newton. And initial velocity of this ball is 10 meter per second. The question is, how high this ball goes. Sama. Okay? Sama je. Case yang sama. Please find out PE plus KE equals to C. To find out C, you solve all the other problem related with that. Okay. So to start, kita nak cari apa dulu untuk solvekan C ni? PE ke KE dulu? Mana lagi senang? Based on what we have here.
KE.
KE. Tapi apa benda yang kita nak kena guna? Ni kena tukar dulu. Because KE is half mv square. M is mass in kg. Jadi kita ada Newton. 7 Newton. Bahagi dulu dengan 9.81. You end up dengan kg. Baru selesaikan KE itu. Okay, selesaikan. Dapat berapa KE dia? Dapat tak? Kan simple je ni. KE equals to half mv square. So first kali kita kena cari dulu M dia berapa. 9.81. We have 0.71. So KE dia ialah half 0.71 10 square. Berapa kita dapat tu? 0.71 kali dengan 100 kali dengan 0.5. 35.5. Okay, 35.5 joules. Ni C value dia. So now we have C value. Can we find out berapa tinggi dia boleh pergi? At the top means KE dah kosong. PE plus KE equals to C. Now at the top, KE equals to 0. Height times weight equals to 35.5. We don't have the height. Weight dia berapa? 7 sama dengan 35.5. So height dia ialah 35.5 divide with 7. 5.1 meter. That is the maximum height the ball able to reach with an initial velocity of 10 meter per second. Itulah gaya penggunaan dia. Okay, boleh?